Welcome. Your day begins now. The future starts now. You will want to pay attention to these gentlemen on stage now because you'll leave with a different perspective on the most important topic of our age. There's no greater use of energy than the creation of intelligence. And we're at that point, the inflection point in human history, arguably more impactful than what happened with the Industrial Revolution with artificial intelligence. However, there is a hiccup on the road, and that's energy and the infrastructure to support it and the resources that are consumed in making the AI so that we can get to the good stuff that we could do using the AI. But we're figuring out how to scale, how to overcome some of the challenges. And along the way, we're actually finding out that the application of AI itself to the energy infrastructure and the development of supporting infrastructure could make the energy system better. So help us think about this, about some of the innovations. I'm very pleased to introduce Chase Lockmiller, CEO of Crusoe, Andrew Feldman, founder and CEO of Cerebras, Alvin Grayling, best-selling digital fellow, Stanford and MIT affiliations, welcome, and Dave Blunden, managing partner at Link Ventures. Give them a round of applause to get them going. Let them know we value their input and what they're doing. Okay, so let's start with you, Chase. We were together just a few months ago in Abilene, Texas, where you are building on behalf of your clients, to include OpenAI, the world's largest energy infrastructure play. And as part of a complex of much bigger ambitions that your company has. And in fact, for those of you who can see from the audience, you'll see some red sand in my boots. I had to buy these boots because I was told I can't tour the Stargate facility in Abilene unless I had tall boots, and Chase and Sam Altman wouldn't take me around because of the rattlesnake. So I had to buy boots. This is the next time I'm wearing them, so the Davos ice is covering the Abilene red sands. So Chase, you owe me $150 for the boots, by the way. But thank you for the tour. Tell me, you've built an extraordinary company really out of nowhere from the perspective of many people who don't follow this area. What is the biggest challenge you encounter in developing energy infrastructure for AI, and what have you learned at Stargate and other places?
I think the energy to power intelligence is a really important trend that's unfolding across the entire ecosystem as adoption of large language models and agents are embedded in human workflows. Just the overall computing infrastructure needs are exponentially growing. And, this type of infrastructure that's being built is actually, it's unlike anything we've ever seen before, because not only is it just a big data center that's hosting a lot of chips, but all those chips are actually fundamentally interconnected with one another. So what we're really building is a data center scale computer. That introduces a lot of complexity and a lot of challenges where things can break, in all of the different connections. And so I don't think there's necessarily one thing that I'm like, this is our biggest challenge. It's like our biggest challenge changes on a daily basis. And it's honestly like a game of whack-a-mole. The supply chain's incredibly complicated. The deployment, the installation, the QA, the testing of all of these different components that ultimately have to work together synchronously in order to produce that ultra valuable spice of intelligence, right?
So, there's a rich complex. There's a whole ecosystem of
the whole ecosystem
that you need to develop here in a way. And I can remember, the night before I toured Stargate, I went to one of the local watering holes to see what the local people think. And they're generally happy, but they're complaining. The rents are going up, the people are coming in, but they're spending money. But one particular complaint people had was about water. They had great concerns. And a local told me, here in West Texas, whiskey's for drinking, water's for fighting, and they're taking our water. And that was the perception. But of course, I know enough to go on the actual tour, kick the tires, thanks to you and Sam Altman. And I saw that the actual NVIDIA chips are water-cooled, they're immersion-cooled. And so your data centers are going to use very little water. So tell us a little bit about that and the decision made there.
Yeah, absolutely. So water is definitely a scarce resource in West Texas. There's abundant power, but water is very scarce. And, we engineered the infrastructure in a way that we wanted to be a great local partner to the community in Abilene, Texas. We're a long-term partner. We're going to be there for decades. So we want to make sure that we're not making enemies, and we're really bringing more than we're bringing more than just jobs, right? We're being a value additive partner throughout the ecosystem. So we actually engineered this large scale AI factory with a closed loop a closed loop direct to chip liquid cooled system. And what that means is each building we fill with 1 million gallons of water, which sounds like a lot of water, but you're actually only filling it one time. And then on an annual basis, the amount of water that's actually used by the data center is on the order of the usage of a single family home. So we're talking about a data center that's powering an abundance of intelligence, but really only using the amount of water of a single family home. So that's pretty big. We've been able to create massive efficiencies on the water usage.
So what you've shown in practice is what Microsoft announced just a few days ago. They said going forward, they're going to be following the same path. That is on water and other resources, even try to be net positive on water. And I think you're giving one example of how to make this transformation happen is to, rather than cutting and pasting old technologies that may have a larger environmental footprint, go to best of class, what's available now, and build for the future, build for sustainability, and you'll have much greater social acceptance and political acceptance. So that's a great example, Chase. Thank you. Let's come to our next speaker. Andrew, you come at this from a different perspective, but I want you to maybe tell us a little bit about how you see energy consumption either as a blocker or enabler of what we're seeing in AI from your vantage point.
But first, thanks for
Hold it very close to your mouth.
Thanks for having me. And this is sort of like combat panel work, isn't it? We are, as chip builders and as system builders in the AI world, we're using a great deal of power. And I think at Cerebras, we are the fastest compute platform for AI. We're orders of magnitude faster than GPUs, and that's because we chose a different approach. We chose to build a chip the size of a dinner plate. When you build a chip like this, you can cut out some of the movement of information, right? And moving information is one of the largest consumers of power in a data center. And so by building big chips, you can do work faster and you can use less energy while you're doing it. I think that's sort of what was one of the basis for us creating the company. And I think as the sort of industry has exploded, what we've seen is sort of an enormous demand for faster inference in particular. People want answers more quickly. And so they're filling up data centers like the ones Chase is making with equipment to deliver answers more quickly. As a community, we're using more power. And we have some obligations. We need to do better work. We need to make our chips more efficient. We need to make our models more efficient. Chase and others are making their data centers more efficient. I think the whole community is coming together to do a better job on this front.
So you talked about how through better engineering, a smarter material science, and even sort of a vision of efficiencies on the chip, you're able to improve energy efficiency and the output of intelligence. How do you think about the question of the Jevons paradox, that, the better you do, the more we're going to demand? We're a pretty greedy lot in here, as you can see.
I think Jevons paradox is BS.
All right, folks, you heard it here first. Okay, debunk it.
I think
Jevons is rolling over in his grave.
Yeah, no, he's not, because it wasn't very interesting. I think when you build things of value, and people use them, and as you're able to drive costs down, they use more of them. There's no great wisdom here. I think it's a very simple proposition, and something we've seen, particularly in the compute world. As we've been able to drive costs down over the last 50 years, compute has moved from a handful of machines at banks to into your watch, and into your alarm clock, and into your washing machine, and into your oven. And we've done that by driving costs down. But at the same time, we drove costs down, we drove efficiency up. The machines we're building, the computers we're building right now are vastly more efficient. And they're bringing value. It's not like people are deploying them and not getting benefit from it. The reason we're deploying so many machines, the reason there's such demand for AI is because we're doing useful work. And that's what matters.
So, sorry, Chase,
I was gonna also comment on, I spoke about a lot of the complexities that we face in deploying these data center scale computers. I think what's really incredible about what Andrew's doing it actually simplifies things in a lot of ways, particularly for the inference use case. You still need those data center scale computers with fully interconnected high performance backend networks that introduce a lot of complexity and a lot of components that can fail for training workloads and training these breakthrough foundational models. But for inference, Andrew actually abstracted away a lot of the complexity of like deploying these large scale clusters into directly into the chip, directly into the silicon, and that actually simplifies things, and it also accelerates things. And so I think as applications get adopted, as usage goes up on the inference side, we're just seeing tremendous growth for demand for the type of hardware that Andrew's building. In addition to the big players like NVIDIA.
Thank you, Alvin. Let's come to you. Alvin, you have a different perspective. Now, we've talked a lot about in the race for AGI. There's obviously a scale has benefits. You have a view that actually scaling AI compute isn't the answer; is part of the problem. So tell me what you mean by that.
Yeah, the audience really want to first pay attention to this. Things that Chase and Andrew are doing are amazing. They're solving real technical problems. But more important than solving the technical problems is actually understanding what is the real problem that we want to solve. Do we need to solve these problems? Do we need to spend $2 to $3 trillion over the next few years to build hundreds of more data centers when we have 5,000 data centers in America, which is actually 10 times more than there is in China and 50 times more than there is in India? So 3 billion people have, one small fraction of how many there are here, right? And so the
short answer is yes.
Okay.
Yes, we do.
Yeah.
So, but Alvin, that's
I agree.
Dominance is we want to have 5 million data centers or 5 ginormous ones that Chase will build.
But that's this. So this is the issue: is why do we want to do this? The current argument is that we are in a race with China, and we have to have the AGI first. We're going to build as many data centers as possible so we can get there before they do. But then when you ask around and you say, well, what does winning mean? Is there a finish line? Nobody can actually tell you if there's really a finish line, right? And you can see, even right now, China has 1/10 as many data centers as we do, but their open source models are actually ahead of our open source models, and their open source models are within a few percent of our leading source models. So really the constraint right now is not necessarily chip. The real constraint right now is actually humans. It's about engineering, it's about techniques, it's about algorithms.
Imagination. That's right. It's complete agreement there.
That's where the scaling is coming from. So trying to build a lot of data centers that we can't even find energy to power may or may not be the solution. When I say it could be the problem, is that because we're build trillions of dollars into a market that may not be able to generate near-term returns, which could actually create a lot of risk in the market and could do some harm in the economy. At the same time, we're actually on the energy side. We probably have the cheapest way to get energy today is through solar. And China makes 90% of the solar cells in the world. If we're in the adversarial relationship with them, it's going to be very difficult, or at least there's additional.
Not helpful.
So respectfully, I couldn't disagree more with you. The race with China is one reason to be building infrastructure, but even without any race unfolding, the real reason to be building all this infrastructure is because there's demand for it. There is economic value that is being produced from the compute, and there is an incredible amount of demand throughout the economy for intelligence that's being produced through AI infrastructure. And if you look around, every innovative AI application company, every innovative AI lab is compute constrained.
Yeah.
They can't do all the things in the roadmap, not because they don't have the ideas, not because they don't have the engineers, not because they don't have the talent. It's literally not because they don't have the money. It's because they don't have the compute.
I fully agree.
There is
we are tremendous. You know why we are compute constrained? Is because we are creating 100 models that are all doing the exact same thing. They're all within 2 to 3% of each other. So why are we doing that? Why are we?
Alvin, propose an alternative. Are you saying that we should give up on chasing superintelligence, or are you suggesting a distributed model, or
no?
Should we sort of hold hands and do kumbaya like a CERN, the big science model of AI? What do you have in mind here? Put something on the table.
So rather than trying to build 100 models that do the same thing and then being constrained on chips, on energy, on talent, on data center space. Why don't we work together? Because AI should be a public good. It should be something that is shared with the world, just like the air is, just like the water is. Nobody's around saying, I want to get the most water or the most air, right? So if we can say energy, if we can say intelligence is something that should be shared, then it should be worked on together. And if we work on it together, we don't need 100-fold the resources that we have today. So it automatically solves, or at least alleviates the constraints that we have today on the.
But just again, in terms of analogies, can you tell us a time where this has worked on of incredibly difficult technological challenge for a new industry? I mean, maybe something others or give it an example.
You just gave CERN as a great example for particle physics. 100 countries in the world got together, putting billions of dollars into a giant collider so that we can take that science that comes out and share it with the world.
But decades later, what have they achieved? I mean, we have a few published papers. That's about it.
No, the CERN was actually the World Wide Web was invented at CERN. So we wouldn't have the internet we have today without some of the work that's
maybe the God particle too. Let's see. We'll see.
And we went
the 40 particle.
I mean, look, I think just from my perspective, there's very few things that haven't benefited from competition. So the idea that we're going to just have a, top-down mandated collaboration for producing a better result, we're ultimately going to lose. I think competition is a good thing. It's going to drive better products and better results for everybody that's consuming these products. And, there is capital to invest in this. And the capital invested is going to not just uplift and build out the compute infrastructure that's needed for these applications, but it also is going to help catalyze the development of the energy infrastructure.
I'm a big energy infrastructure. Let me bring Dave into the conversation. Dave, you're a leading venture capitalist. You're a financial investor in this. You've heard the debate. Give us your perspective on how you see this.
I'm not just an investor. I was the first person at MIT to build a neural net at all.
You're an investor who knows something, which is rare.
And a huge fan of. So if you look at that chip, that's probably as high tech and as advanced an achievement as humanity has ever done. But the trillion transistors interacting on a single chip, and when Alvin says it's like air and water, the analogy is good and bad. It's good in the sense that it is a global need. Every human being is going to need AI. It's not good in the sense that if I drink this water, when I'm done drinking it, I have had enough water, I don't want more water. The demand for AI is infinite. And as it gets more and more intelligent, the things they could do to benefit humanity grow exponentially to infinity. And so I think that what we're talking about right now has unlimited demand, and the constraints that we're talking about, those are the critical things for us to figure out on this stage. And so from an investor's point of view, I'm constantly looking for, okay, what's the next constraint? I'm assuming that the demand will go to infinity. And I care about topics like when Chase says, look, I'm building a $500 billion data center, and it's shifting back and forth between training and inference. And you look at that chip, which is orders of magnitude faster at inference than an NVIDIA GB300, but is not connected from end to end, like from one end of Abilene to the other is what? Like it's kilometers. And to do training, that all needs to be interconnected. To do inference, it can be local. So completely different infrastructure for the two use cases in this ridiculously fast-changing environment. And the other thing that Chase has to deal with is he's building this thing as fast as humanity has ever built any piece of infrastructure. And the chips are changing as he's finishing one end of the data center. The other end needs to be replaced. It's the most wacky human endeavor in the history of the world. And I think we can debate the race with China, and we won't conclude it on this stage. But we really should be identifying like what happens in the next 1 year in terms of what we run out of. Is it going to be the fabs? I think it's all constrained at the fabs. You tell me.
All constrained at the fabs.
Yeah.
Both memory fabs and logic fabs. So we can't get enough chips, and the industry can't get enough memory.
What are you doing to get around the fab constraint?
Well, we don't use that type of memory, number one. So we there's not a lot you can do. The fab market is two, right? Is TSMC and is Samsung, and at aggressive geometries, it's TSMC.
And you're making those with TSMC?
We're making these with TSMC.
Yeah. Can I add a point to what you're saying though? It says I totally agree. On certain areas, there's going to be an increase in demand. But also on the other side, these models are getting smaller and smaller and more capable as smaller models, which means at some point they're going to run on your devices that are at the edge, whether it's a phone or you mentioned,
I'm not sure that's true. Are they getting smaller?
well, smaller models are now just as capable as the trillion per annum model of a year ago. Right, you can get a 100 or a 50 or 30 billion per annum model that will run on a PC and soon will actually run on a phone.
Well, let me ask this question. We've skirted around this question a couple of times, and that is the race with China. The framing, of course, we're going to have President Trump arriving shortly and giving a speech a little bit later today. The framing is on American dominance and abundance of energy, dominance of AI. There's a technology policy unveiled just a couple of months ago that talks about sort of, really overall the way that in military terms one talks about superiority, dominance. That's what America's official policy is, and heading in that direction. How does that fit with some of the things we're talking about? That is, resource constraints, whether it's chips or whether it's energy or whether it's infrastructure, and alternative models that are coming out of China that are frugally engineered, that may be using a distributed approach. India as well has other approaches to AI. Do the resources that are available to the American approach of innovation in AI, are they suited to the purpose? Or is it possible that some agile and frugal competitor, even if it's cheap and cheerful, may be able to get ahead because of the resource constraints? Let me start again over there.
Well, I'll throw this to Andrew and Chase because they literally are the world's leading experts on this topic. But in the political arena, there's always a big tendency to talk about energy, because we're used to talking about it. It's geopolitical. It ties together countries. But Andrew just said what is absolutely true. Everything is constrained at the fab level. And the U.S. has already embargoed the most advanced chips. I don't know if you can sell your chips in China. Can you? No, you can't. So that's what's going to happen is we're going to cut off access to all the fabs to China. And we're going to keep moving the fabs from TSMC as aggressively as Donald Trump can bring.
Has that ever worked? The cutting off access. Either there's it's porous. We're in the Middle East, for example, or it's popular, or it encourages a different and better kind of innovation.
Being around my row is the biggest thing since World War II, and it did work during World War II very clearly. But you're right, there are very few examples since World War II. Go ahead, Andrew.
It mostly just kicks the can down the road. Right, it doesn't keep it from them and keeps it from them sooner. Right,
but it also encourages. It does encourage ways around. Right, water finds a way around obstacles, and so it may encourage some other kind of innovation that would not otherwise have happened. Right, maybe better.
Right, but right now in the chip world, there is a choke point, and that's ASML. Right, you can't make a fab without ASML, and by controlling where those machines go, you can control who can make chips, and so.
The Dutch don't like it very much. ASML is a Dutch company, and not only that, but I know from knowledge of the company that the Dutch are quite unhappy with those constraints.
Of course, they are.
If the U.S. makes an enemy of Europe, which we'll find out in a couple of hours, if that's what we're doing our best, they may go a different way. Already, if you're a U.S. citizen at ASML, you are ring-fenced away from the most important secrets. The U.S. citizens have become the pariahs at the company because they're concerned that there may be some, illegal action from the State Department or defense agencies or so on. So we've already created a challenge for ourselves, and that's is that the right way to think about the problem?
I think the problem is we've framed it as a zero-sum game, and we framed it as the faster you get this type of intelligence, the more intelligence you get, right? So it's a recursive system. And in that sort of environment, it's a winner take all. Getting there first means you win. And because then you get there faster and faster and faster, your intelligence sort of moves up exponentially. In that environment, it necessitates a sort of nasty competition. And what my colleague here is suggesting is it need not be that way. And it need not be that way, but it is that way now. And we've got a model where we do if we want to change it.
It's a choice.
We were working, throughout 2000, 2010, 2015, most of us in the computer industry were working with Alibaba and Didi, ByteDance. We were happily collaborating with them. Our governments chose to take a path that was really sort of confrontational and difficult. And so what can we do as...
I totally understand the perspective you're coming from, but I think we still have a chance to actually make a change because that decision was something that we chose to do, but we can also choose to undo.
Trace, why don't you jump in here?
Yeah, so I agree with a lot with Andrew, and I sort of take this perspective. It's frequently been framed as a race, but I actually don't view it as a race. If China's ahead or behind the U.S., I don't think it changes the utilization of AI infrastructure and AI models to drive productivity in those respective economies. But that said, when we think about sort of the competition between the U.S. and China, I think there's like 5 key components that really go into producing AI and producing AI intelligence at scale. The first is energy. The second is data centers. The third is chips. The fourth is people or sort of algorithms. And then the fifth is data. And when I sort of look at those 5 different dimensions that we're sort of competing on, in a lot of ways, China is very much outcompeting the United States on the energy vertical. They are building and investing in a lot more abundant energy throughout China, better compared to the United States. They're on a massive acceleration path. The U.S. I think is way ahead of China on the chip side. Anyway, those 5 key verticals. The chip side, I think the United States is actually way ahead of China, thanks to the efforts of Andrew and Jensen and Lisa and a lot of the innovation taking place in the United States. I think a lot of the other verticals we're sort of on parity. I think on the data center side we're slightly ahead. On the data, it's unclear. I think there's a lot of internet data that's available to both sides, and a lot of the private repositories of data. It depends on how you actually utilize that data most efficiently. And then on the researcher side, the algorithms and the research side, I think we're kind of on parity. I think there's this U.S.-centric perspective that we have the most innovative people in the world. We have the smartest people in the world. Half the researchers in AI in the U.S. are Chinese. And there's an incredible amount of engineering talent coming out of China. So I think on that domain, it's very much like a toss-up to me. So we're sort of ahead on certain verticals, behind on others, and it's important for the United States to recognize the game on the board and really invest in the areas where we're behind and really press our advantage where we're ahead.
Chase, that's I think a lovely handicapping of where things are and a good way to heuristically break things down. I'd add one other category, and that is adoption, utilization. And here, there's a lot of evidence that in China, they're rushing to use even imperfect models or less than frontier models of AI in consumer products and services, and they're learning. And what I know, because my last book was on the history of innovation. It's a book called Need, Speed, and Greed, which kind of captures the whole topic that we're discussing today. But one of the most profound lessons from the history of innovation is that it is not the company or the inventor or even the country that develops an invention that creates the most value out of it. And it is the one that adapts, adopts, diffuses most enthusiastically and creatively that gets the most value. And that's the difference between invention and innovation, is the value creation.
Yeah,
That that's an open race. Anybody can join that race.
And I want to add a point to that, is that in fact, because they have this thing called the AI Plus plan, which is all about how they can put AI into 10 different industries, from agriculture, medicine, education, manufacturing, etc. And they are pushing it out as part of their strategic plan. If America did that, we actually have a bigger problem, because they have a social safety net. So if they have displacement of workers, they actually have people that can be taken care of. America, if we quickly diffuse this technology and we have mass displacement, we don't have a safety net. We have 40% of the people in America that does not have more than a month of savings. So the faster we get there and the faster we diffuse, the faster America gets into trouble.
Chase, I'll give you a final word, and then we got to wind up here.
Yeah, no, I think your point on the adoption is incredible. What adoption drives also is utilization and economic value creation, which drives more investment in energy, which drives more investment in data centers, drives more investment in chips, and actually provides this massive improvement in the data quality that leads to better algorithms. So it's actually an incredible flywheel that actually drives massive advancement. So I think it is really, really important to push adoption. That's an incredible point you made.
I'm glad you landed on that point. We're just coming out of time, so I want to underline that point. Innovation is fresh thinking that creates value. Even though we're here at the MIT Dome, and I can see 3 brass rats on stage, which pleases me to no end, we must not make a fetish out of invention. We should look for value creation, value for shareholders, value for society, for citizens, and for the future generations to come. I hope the fresh thinking on this stage, including some disagreements that you won't find elsewhere, have given you food for thought so you'll think again on this topic. Please join me in thanking my panelists, and we hope you have a video at Davos.